Hey guys, hope you're all doing well today. I want to talk about something very interesting and also a useful topic which is so easy and more effective that you start implementing it immediately. Most of us have been in an intense hot conditions, be it due to hot weather during summer or intense workouts or etc. Let me tell you briefly that intense heat for the body is just very bad. It will lead to all sorts of problems, from heat exhaustion to eventually heat stroke, which can become deadly if action isn't taken. First of all, our body tries to remain in homeostasis, which means our body systems regulate and maintain themselves to operate within a very narrow band of temperature. It is around 98.6 Fahrenheit or 37 degrees Celsius, and it doesn't want to be too hot or too cold, but just right for you. So when we get hot excessively, our core body temperature begins to rise. Now here where all sorts of problems begin to happen in the body, and it's bad for all tissue health. And if our brain heats too much, neurons start dying. And we have in all our cells called enzymes. For example, the enzyme lipase breaks down the fat which we eat, and the enzyme protease breaks down the proteins that we eat. And when the body gets too hot, these enzymes start to lose their shape and won't be able to function properly in our body. And if our core body temperature rises above 104 Fahrenheit or 40 degrees Celsius, this is where things get to start really bad, which causes brain dysfunction, which leads to thinking problems. Muscles break down, which sends toxins into your bloodstream. And the longer your body temperature remains high, the greater your risk of complications from organ damage or eventually death. Now you understand why getting too hot is just plain bad for your body. So you should avoid it by all means. And now, how can we cool our body quickly so as to reduce the core body temperature? Well, there's one of the few important ways which is very well tested in the lab and also in the real world conditions, which is proven to reduce the temperature. Imagine you come home after being outside in the intense summer heat. Your first instinct is go to the sink and splash some water on your face, and almost immediately you start to feel better. But why does getting your palms in contact with water and splashing it to your face make you feel cooler overall in general, and it creates a sense of relief? Those are relatively small areas of the body. The answer lies in a special type of skin called the glabrous skin. This is very interesting, and today we are going to explore how this special type of skin acts like a natural cooling radiator for our body. Not all skin on our body is the same, except for glabrous skin. Most of the other areas of the skin has hair and hair follicles, but certain parts of your body are hairless. This includes the palms of your hands, the soles of the feet, lips, and parts of the face. This hairless skin is called glabrous skin. But the reason this skin exists isn't just for gripping or touch. It plays a critical role in temperature regulation. Inside a glabrous skin, there are specialized vascular structures called the AVAS. These structures allow blood to flow directly from arteries to veins, bypassing the tiny capillary networks. Under the normal circumstances, blood flows like this, from artery to capillaries to vein. But in glabrous skin, AVAs bypass the capillary, and when the body needs to release heat, these AVAs open widely, allowing large volumes of blood to rush near the surface of the skin. This warm blood releases heat into the surrounding environment. You can think of glabrous skin as a built-in heat radiator for the body. When our body becomes overheated, our brain, particularly a region called hypothalamus in the brain, activates cooling mechanisms. It sends signals that cause blood vessels in the skin to widen, more blood to flow toward the surface of the skin. This process is called vasodilation, which means expansion of the blood vessels. Glabrous skin is especially important during this process because its AVAs can increase the blood flow dramatically. This allows the body to dump heat much more efficiently. But how did the modern understanding of this come about? This is fascinating too. The understanding of leveraging glabrous skin to reduce the body heat is largely attributed to the research which is conducted by the Professor H. Craig Heller and Dr. Dennis Gran at Stanford University. Their journey began with a fundamental question in the mammalian physiology. How do well-insulated animals, such as black bears, manage to dump heat during the hot weather without shedding their thick fur and fat layers? They discovered that bears, and in fact nearly all mammals, have built-in radiators, hairless areas of the body that feature extensive networks of veins very close to the surface of skin. Rabbits have them in their ears, rats have them in their tails, dogs have them in their tongues. Heat transfer with the environment significantly occurs on these relatively small patches of the skin. When you look at the thermal scan of the bear, the animal is mostly indistinguishable from the background. But the pads of the bear's feet and the tip of the nose look like they are almost on fire. These networks of AVAs seem exclusively devoted to rapid temperature management. They have highly variable blood flow, ranging from negligible in cold weather to as much as 60% of total cardiac output during hot weather or during exercise. As these two researchers tested the effects of this type of cooling during the intense workout, the results were shocking. They made a glove which incorporated this cooling technique, which they tested it for different use cases. But the glove's effects on the athletic performance didn't become apparent until the researchers began using the glove to cool a member of the lab, the confessed gym rat, and the frequent co-author Wincav. Between sets of pull-ups, the glove seemed to nearly erase his muscle fatigue. Near multiple rounds, cooling allowed him to do just as many pull-ups as he did with the first time around. So the researchers started cooling him after every other set of pull-ups. Then in the next 6 weeks, he went from doing 180 pull-ups total to over 620, which was set by the Heller. That was a rate of physical performance improvement that was just unprecedented. Some other examples include wearable cooling devices, which could also help patients with multiple sclerosis who suffer symptom intensification. When experiencing high environmental or body temperatures, some multiple sclerosis patients using the current version of the technology have been able to leave their air-conditioned homes in the summer season and return to playing golf and engaging in other activities in spite of warm weather. And another important example include in pre-hospital settings, traditional cooling methods often involve placing ice packs on the neck, groin, and armpit as a way to bring down the heat. However, a study comparing this method to the Glabrous skin cooling, the face, palms, and the soles, found the latter to be twice as much effective. That is staggering, really. So, multiple other studies have proven that this type of cooling to the glabrous skin is indeed helpful. In fact, they have developed a heat-reducing gloves at Stanford, which is turned into a product which is called as the Cool Myth. You can check their website for more details, where they mention how it is helping soldiers, professional athletes, people with personal protective equipments, and also during Ebola epidemic and etc. One important thing to note is a frequent misunderstanding in the application of glabrous cooling is the belief that colder is better. In fact, applying ice or water that is too cold to the palms can be counterproductive. If too cold water or ice is made to contact the palms, it causes vasoconstriction, which means the AVAs shrink in diameter, which significantly reduces the heat transfer. So make sure it is not too cold, but just cool enough. So finally, what's the takeaway for us? For people in home or offices, what you can do simply is you could get a high quality aluminum water bottle and fill it with cool water. This setup will have good thermal conductivity. But you would need to shake the bottle while holding it in order to avoid thermal barriers, which means a layer of heat being stagnant at the walls of the contact surface. You also need to refill bottle frequently, and it will warm up quickly in warm conditions which you are using. So why only aluminum? Because it has the high heat conductivity compared to other materials such as plastic bottle. You can still use plastic bottle, it won't be that effective, but it's better than none. You can also soak your hands and foot in the water. Whenever you are at home or elsewhere, these techniques are useful. The research into this type of cooling has implications far beyond the athletic field or the battlefield. As urban heat becomes more intense, Understanding how to efficiently cool the human body is helpful for our own health. In many parts of the world, summer temperatures are reaching levels which are where outdoor labor becomes very dangerous. If workers in construction, agriculture, or logistics can be provided with simple palm or face cooling breaks or wearable devices, the incidence of heat exhaustion or heat stroke could be significantly reduced. The core takeaways for managing body heat during summer or hot weather or during intense exercise are very clear. Target the palms, the soles of the feet, and the face. Avoid vasoconstriction trap of excessive cold and ensure high thermal conductivity with constant movement to prevent a thermal barrier. Leveraging the radiator within is the most efficient science-backed method for maintaining a thermal homeostasis in an increasingly hot world. I hope this information has given you some insight into how our body deals with excess heat. When we understand the biology behind these mechanisms, it becomes easier to make better health decisions for ourselves. And if you think this might be helpful for someone who struggles with excess body heat, you may please consider sharing what you learned in this video with them. Please take care of yourself and thank you for watching.